The universe, a word that stretches the imagination to its limits, conjuring images of infinite stars, swirling galaxies, and mysteries that have haunted humanity since we first gazed upward. What is happening out there in the vastness of space? How do we, fragile beings on a pale blue dot, begin to make sense of it all? The cosmos is not just a place, it is a story, a tapestry woven from the threads of time, matter, and energy. To understand it, we must embark on a journey, one that takes us from the fiery birth of stars to the silent whispers of black holes, from the microscopic dance of particles to the grand choreography of galactic collisions. This is the story of the universe, and it is a story we are only beginning to comprehend. Let us begin where it all began, the Big Bang. Some 13.8 billion years ago, in a moment so fleeting it defies comprehension, the universe exploded into existence. All that we know, every star, every planet, every atom, was compressed into a singularity, a point of infinite density and temperature. Then, in less than a trillionth of a second, it expanded, unfurling space and time itself. This was no ordinary explosion. It was the creation of everything. The early universe was a searing, chaotic soup of energy, where particles collided with unimaginable violence. As it expanded, it cooled, and from this cooling emerged the first building blocks of matter: quarks, electrons, and photons. Within minutes, these formed the nuclei of hydrogen and helium, the simplest elements that would one day fuel the stars. But what is happening in space today, billions of years later? The universe is no longer that primordial furnace. It has grown, stretched, and evolved into a vast, structured cosmos. Galaxies, enormous cities of stars dot the void, each a testament to the forces that shape reality. Take our own Milky Way, a barred spiral galaxy some 100,000 light-years across, home to roughly 200 billion stars. It is a bustling metropolis of cosmic activity, where stars are born in glowing nebulae, live out their lives, and die in spectacular explosions that seed the universe with heavier elements like carbon, oxygen, and iron, the very stuff of life. Stars are the engines of the cosmos. In their hearts, under crushing pressures and temperatures reaching millions of degrees, hydrogen atoms fuse into helium, releasing energy that powers their radiance. This process, nuclear fusion, is the alchemy of the universe, transforming simple elements into the complex materials that form planets, moons, and even us. But stars are not eternal. A star like our Sun will shine for about 10 billion years before it exhausts its fuel, swells into a red giant, and eventually collapses into a white dwarf, a dim, cooling ember. More massive stars meet a more dramatic fate, exploding as supernovae, their remnants collapsing into neutron stars or black holes. Black holes, perhaps the most enigmatic objects in the universe, are regions where gravity is so intense that not even light can escape. They form when massive stars collapse or when vast amounts of matter converge, warping space-time into a singularity. Yet black holes are not merely destroyers, they are cosmic architects shaping galaxies. At the heart of nearly every large galaxy lies a supermassive black hole, millions or billions of times the mass of our Sun. These titans orchestrate the dance of stars and gas, influencing the structure and evolution of their galactic homes. In 2019, the Event Horizon Telescope captured the first image of a black hole shadow in the galaxy M70, a milestone that brought these invisible giants into focus. What is happening around a black hole? Matter spirals inward, forming glowing accretion disks that emit powerful jets of energy, piercing the cosmos across vast distances. Beyond stars and black holes, the universe is a stage for grander spectacles. Galaxies collide, their gravitational embrace stretching and twisting their spiral arms into chaotic bridges of stars and gas. Our own Milky Way is on a collision course with the Andromeda Galaxy, set to merge in about 4.5 billion years. This will not be a violent crash, but a slow, majestic blending, reshaping both galaxies into a new elliptical form. These collisions are not destructive, but creative, sparking bursts of star formation as gas clouds compress and ignite. But what of the spaces between these cosmic landmarks? The universe is mostly empty, a vast expanse of dark, cold void. Yet even this emptiness is alive with activity. The interstellar medium, a thin haze of gas and dust, permeates galaxies, providing the raw materials for new stars. The intergalactic medium, even sparser, connects galaxies in a cosmic web with filaments of gas threading through the void. And then there is the cosmic microwave background, the faint afterglow of the Big Bang, a snapshot of the universe's infancy that still permeates space, detectable as a faint hum of radiation. Yet for all we see, stars, galaxies, nebulae, the visible universe is but a fraction of the whole. Approximately 27% of the universe's mass energy is dark matter, an invisible substance that exerts gravity but emits no light. It binds galaxies together, preventing them from flying apart under their own rotation. We infer its presence from its gravitational effects, yet its nature remains one of the great mysteries of modern science. Is it made of exotic particles? Something else entirely? We do not know. But its influence is undeniable, shaping the large-scale structure of the cosmos. Even more mysterious is dark energy, which constitutes about 68% of the universe. Discovered in the late 1990s, dark energy is the force driving the universe's accelerating expansion. Unlike gravity, which pulls things together, dark energy pushes them apart, stretching space-time itself. What is it? A property of space-time? A new kind of energy field? Its discovery overturned our understanding of the universe's fate, suggesting that it will not collapse in a big crunch, but expand forever, growing colder and emptier with time. Amid this cosmic drama, we search for signs of life. Are we alone? The question burns in our collective imagination. Exoplanets, planets orbiting other stars, offer tantalizing possibilities. Since the first confirmed exoplanet in 1995, thousands have been discovered, some in the habitable zone, where liquid water might exist. Missions like NASA's Kepler and TESS have revealed a universe teeming with planets, from gas giants to rocky worlds not unlike Earth. In 2024, the James Webb Telescope detected potential biosignatures, chemical hints of life, in the atmosphere of an exoplanet, though confirmation remains elusive. The search continues, driven by the profound question: is life a cosmic fluke, or is it woven into the fabric of the universe? Space is also a laboratory for the fundamental laws of physics. Particle accelerators on Earth pale in comparison to the natural experiments occurring in the cosmos. Cosmic rays, high-energy particles from supernovae or black holes, rain down on us, offering clues about their extreme conditions of origins. Gravitational waves, ripples in space-time from cataclysmic events like black hole mergers, were first detected in 2015 by LIGO, opening a new window into the universe. These waves carry information about events billions of light-years away, allowing us to hear the cosmos in ways we never could before. What is happening in space is not just a question of physics, but of philosophy. The universe challenges our sense of purpose and place. Are we significant in this vastness, or are we an accident, a fleeting spark in an indifferent cosmos? The Copernican principle reminds us that we are not at the center of the universe, yet our ability to ask these questions suggests a unique role. We are the universe observing itself, a consciousness born of stardust, seeking to understand its own origins.